Today we are going to learn how to find the network address, broadcast address, first IP address in the range, then last IP address in the range. Now first of all, network address. What is network address? A network address identifies the entire network. Now look at here very carefully. A network address identifies the entire network, not a specific device. What does it mean? So that means you cannot assign a network address to a particular device. Like PC, it has an IP address, but there is something called network address which you cannot assign to a PC. This is not possible, okay? It is the first IP address in the subnet. What is it? We'll have a look. In order to find it, if you make all host bits zeros, okay, in binary, then you will get it. Routers use it to identify the network. Now let's come here. Let's say this is an IP address. So if you look at here, what kind of IP address is this? This is class C IP address. So for any class C, the CIDR is /24. The CIDR is /24. If you convert /24 into the subnet mask, you will find 255.255.255.0. Now look at here very carefully. What did I say? Whatever is the CIDR value is your network bits. That means you have 24 network bits. So if you have 24 network bits, how many host bits you have? First of all, the total number of bits are 32. And if you subtract 24 network bits, you will left with 8 host bits. So if you look at here, it has got network portion has 24 bits, host portion is 8 bits. Okay. Now, if you convert this IP address into the binary, it will be something like this. And if you convert this subnet mask into binary, it will be something like this. Now look at here very carefully. There are 24 bits that are network portion. Now if you count, you will find 8 is 24. Okay, these 24 bits are network portion. There is another formula as well. Okay, the other formula is as long as you can see one in the subnet mask. So if you look, as long as you can see 1 in the subnet mask, that means that's the network portion. The time you see it starts with zeros, that's the host portion. The time you see it starts with 0, that's the host portion. Okay, now I will show you something. Okay, what I wanted to show you, let's say if you have a subnet mask, it will never be something like 255.0.0.255. It will never be something like that. It will always be, let's say 255.255.0.0 acceptable. The time you go to 0, you cannot go to any other number. Now look at here very carefully. We know that this cannot be and this can be. Let's look at here. .192.0.0. Can this be a subnet mask? Of course it can be a subnet mask, because the time you went to 0, you never went to a number anymore. Okay, so in other words, if you look at here in the subnet mask, when you are writing ones, the time, let's say you can stop here 1 and you can start 0 from here, so everything will be 0. That's completely fine, no problem. The time you start with 0, you cannot go back to 1 anymore. Okay, and of course, you know, from binary you need to do the calculation for the decimal. Now look at here, this is the network portion and obviously this is the host portion. Never ever touch network portion. Network portions are fixed. You cannot change anything in the network portion. You cannot change anything in network portion. Host portion, you can change anything and everything. It doesn't matter. Okay, so why this is the network portion? First of all, /24, 24 bits. So any correspondence bits that you can see from the IP address, comparing with the like subnet mask, you cannot touch it, okay, because that's the network portion. The only portion is the host portion. What it says here, this is the most important one. All host bits 0. Now make all the host bits now exactly the same. You wrote the same IP address. This is the network portion. This is the network portion. And when you come to the host bit, make all host bits zeros. So if you make all of them 0, you will find 192.168.1.0. So the network is 192.168.1.0. Now look at here very carefully. I gave you, like, think about the table. The first number is 0 and the last number of the table could be 100, could be 99, doesn't matter, but it always starts with 0. So if you look at here, this is the first address of the subnet. This is the first address of the subnet, first IP address of the subnet, and this is the network portion. And sorry, this is the network address, and it cannot be assigned to a individual device. Now look at here very carefully. It may not be 0 always, okay? Depending on the circumstances, it may not be 0. It may not be 0, okay? It depends on a lot of things, okay? But you do like this, whatever you get is the network address. Now let's look at broadcast address. What is a broadcast address? Okay. First of all, according to the definition of broadcast address, if your computer, this is a computer 192.168.1.1, this is another computer 192.168.1.2, this is another computer 192.168.1.5. Let's say in this way you have like 1.100 until 1.100. If this computer wants to send to all of the computers at the same time, he will use the broadcast address. So broadcast address is used to send packets to all devices in the subnet. So if it is used to send packets to all devices in the subnet, obviously it is clear that you cannot use it on a particular device. So the network address and the broadcast address cannot be used on a particular device. It is the last address in the subnet. Make all host bits ones. Now let us work with this one. So this is the IP address and this is the subnet mask. We know the network portion. This is the network portion, and you cannot make any changes in the network portion. The only changes you can make in the host portion. This is the host portion. This is the where you can make any changes. So if you look at here, you have ones here. You cannot make any changes on the top. However, if you have 0 here, if you have 0 in the subnet mask, you can make changes to the corresponding bits on the top in the IP address. Okay. So if you have 0 in the subnet, if you have ones in the subnet mask, you cannot make any changes in the corresponding bits, but if you have zeros, you are free to make any change. Now look at here very carefully. This is the same number. This is the network address. We know that last host bits are 0. Okay, set them to 1. Okay, now what you need to do actually here, you need to set them 1. So 1 2 3 4 5 6 7 8. So if you set them to 1, you will find 192.168.1.255. okay, so if you take this number 111, okay, so if you do here binary to decimal conversion, so 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4, 2 to the power 5, 2 to the power 6, 2 to the power 7. And if you do that, it will be 1, 2, 4, 8, 16, 32, 64, 128. And if you make them all ones, and if you add them, you will find, if you add the values, whatever is 255, okay. And that is the last value that you can get, and this is broadcast address, and you cannot use it on any device. Now, let's look at here very carefully. Usable host address. First of all, if you have 8 host bits, how many numbers you can produce from 8 host bits? There is a formula, is 2 to the power number of host bits. That number of IP addresses you can produce. Now, if you do 2 to the power 8 is 256 IP addresses you can produce with 8 host bits. But there is a problem. What is the problem? There are 2 bits that you need to always subtract. So 256 minus 2 it will be 254 usable IP. Usable IP. Why usable IP? Just remember, there is something called network address, there is something called broadcast address, which we cannot assign it on any device. Okay, so we will have only 254 usable IP address. We'll have 254 usable IP addresses. Now look at here very carefully. The network address is 1.0. We already know that. The broadcast address is 1.255. This is the first address. This is the last address. They cannot be assigned anywhere. What will be the first usable address is 1.1. Second usable address 1.2. Third is the last host will be 1.254. Now here, if you look at here very carefully, this is the network portion. There is no change in the network portion. As I said, you cannot make any changes in the network portion. This is the network portion, no changes. This is the network portion, no changes. This is the network. The host portion, so if you look at here, this is the host portion, this is the host portion, this is the host portion. So host bits, you can change it in any way, and this number will keep on changing. Okay, now look at here very carefully. Let's do something with class B. Okay, that was with class C. Let's do with class B. We know that for network address, all host bits will be 0. Now look at here. We have an IP address 172.16.45.10/16. How can we understand it is class B? Look at the first octet. Look at the first octet. By looking at the first octet, you will be able to say it is class B or not. Check the range of class B. Okay, check the range of class B. What is the range for class B? So if you remember, for class A, it's 0 to 126. For class okay, sorry, I made a mistake here. 1 to 126. For class A is 120 126. For class B is 128 to 191. For class C is 192 to 223. I think so. Okay. Now look at here very carefully. This 172 lies between 128 to 191. So this is class B. Okay. This 172 is class B. Now look at here very carefully. If it is a class B, what did I say? Because these are the things that you need to memorize. Okay. For class A, the default CIDR is /8. For class A, the default CIDR is /8. For class B, the default CIDR is /16. For class C, the default CIDR is /24. Okay. For class B, the default CIDR is /16. 16, the subnet mask is 255.255.0. Now look at here very carefully. If you get the binary of this 172.16.45.10, it will be something like this. Now, what did you look at here is the subnet mask. The subnet mask is 255.255.0.0. So this is the subnet mask. What is the network portion? This is the network portion. This is the network portion, and rest of this is the host portion. So this is your host portion. This is your another host portion. Okay. Because if you see zeros in the subnet mask, any binaries corresponding to zeros on the IP address, you can change it. Now look at here very carefully. According to the definition of the network address, make all host bits zeros. So this is a host portion, this is a host portion. Make everything 0. But you cannot touch here, so it will be the same. 172.16.0.0. 172.16.0.0. Now look at here very carefully. According to the broadcast address, make all host bits zeros. Now again, this is the host portion. Okay? And this is the, because everything is 0 here. If this is the host portion, make all host bits. So make all host bits once. So make them on, make them on. Okay? So 172.16.255.255. If you do this one, you'll find this one. So this is the broadcast address for class B. So basically in class B 2 octets will be impacted. Now usable host, again you know that how many host bits you have in class B. Class B is /16, so there are 16 network bits. Therefore you have total 32 minus 16 is equals to 16 host bits. Okay, simple. The formula for finding the number of IP address is 2 to the power host bits, which is 2 to the power 16. So 2 to the power 16 is 65336, and you need to subtract 2. Why you need to subtract 2? Because there is a network address and there is a broadcast address. They cannot be assigned to any device. Okay, so you will have these many usable IP address. Now if you look at here, according to the formula, 00 is the network address, 255 is the broadcast address. Now look at here very carefully. People sometimes they get confused. If I give you 0, 1, what will be the second number? 0, 2. What will be the third number? 0, 3. So if you look at here, this 0 remains fixed. Okay, you cannot make any changes in this 0, but 1, 2, 3 will keep on changing. So if you look at here, this 0 will remain fixed, but 1, 2, this will keep on changing. 254 is the so if you look at here, you will reach something like this. (172.16.0.1), 172.16.0.2, 172.16.0. The max it can go is 255. Is this a broadcast address? Is this a broadcast address? The answer is no. Why? Because we already know that this is the broadcast address, 255.255. But here you have 0.255. So this is an IP address. Now look at here. Once it reaches 255, it cannot go to 256. So what will happen? It will become 172.16.1.0. Is 0 network address? Is it a network address? The answer is no. Why? Because we already know that 0, 0 is the first address, and which is the network address. Then it will become 172.16.1.1. Then it will become 172.16.1.255. Then again it will increase 1. So it will increase 172.16.2.0. So when it reaches 2.255, it will become 3.255. Then it will become, in this way it will keep on increasing. Now look at here very carefully. If it keeps on increasing like that, you will have one day 172.16.255.255, and after that you cannot make it 256, and you cannot make it 256. You cannot change it anymore. So this is the broadcast address. You already know that this is the broadcast address. The first usable address is 0.1. Last usable address is 255.254. Because after this you will have 255.255 and you will have no more. So this is the last usable host. Now again come to class A. So according to the formula I said 10, it starts with 10. 1 to 126 is class A. By default is /8. /8 means there are 8 network bits. So how many host bits you have? 32 minus 8 network bits. So you will left with 24 host bits. So if you look at here, the maximum number of host bits that you can have is in class A, because you have maximum number of host bits. Okay, now let's come here. This is the IP address and this is the subnet mask. The network portion is this. Can you make any changes in the network portion? I cannot make any changes in the network portion. However, if you look at here, the host portion is this. Why? Because you have zeros here. In correspondence you have zeros here. So you can make any changes in this portion. This is your host portion. Whatever you want, you can make it here. Now, according to the formula, set all the host bits zeros. So if you make everything 0, you will find something like 10.0.0.0, and this is the network address. This is the network address. So if you look at here, this is the network address. Okay. Any questions? No. Okay. Now look at here very carefully. Broadcast address, make all host bits 1s. So if you come at here, the same thing. If you come at here, this is your host portion, make all the host bits once, and it is 10.255.255.255. Okay. So this is the host portion, this is the host portion, this is the host portion. So you make everything 0 in the host portion, you get 0, 0, 0, because you cannot touch the network portion. Okay. Now again, the formula is 2 to the power, the total number of IP address you can produce, 2 to the power h. The total number of IP address will be 2 to the power 24, which is 16,777,216. Now there are two addresses. One is the network address, another is the broadcast address. That cannot be assigned to any device. So you need to subtract 2 from here. So 214 will be this number of usable IP address. You can produce this number of IP addresses and you can assign it to the users. Okay. But however, this is the total. This is the total. Now again, if you look at here very carefully, the network address, all host bits zeros, the broadcast address, all host bits ones. Now look at here very carefully, 10.0.0.0. What will be the next number? 10.0.0.1. In the same way, you will go to 10.0.255. Then you will find 10.0.1.250. Okay. Then you will go 10.0.1.255. Then when it is 255, it will keep on increasing. 10.0.2.255. Like 2.0, 2.1, 2.2, 2.3, 2.255. In the same way, it will keep on increasing, and when it reaches 255.254, this is the last usable IP address. This is the last usable IP address. After 254, it will become 255, which makes the broadcast address, and that will be the end of this address range that you can assign on the user. That will be the end of this address range that you can assign on the user. In this way, you can calculate the 5th usable host, the second last usable host. You just have to take time and you just need to find all these things.